Let us check this one. James takes out a loan of 62,500 at an interest of 12% per annum compounded quarterly. If James makes quarterly payments that start immediately, calculate the value of each payment to amortize. To amortize simply means to pay in full. Calculate the value of each payment to amortize the loan after a full 10 years have passed. So the period here is 10 years, but James is starting immediately. James is starting immediately. And if you could look at this question, we are going back in time. We are given the value of F, which is the amount of the loan, and we are required to calculate the amount of fixed quarterly month payment. So as we go back in time, remember we use this formula 1 minus 1 plus I raised to exponent of minus n all over I. So let us write down our data. We have F, which is the loan amount. It is 62,500. The quarterly monthly payment, that is what we are calculating. The period here, it is 10 years, but it is said to be compounded quarterly. Therefore, we multiply this by 4, which will give us 40. Which will give us 40 quarterly payments. 40 quarterly payments. But James makes a quarterly payment that starts immediately. So if they start immediately, that simply means there is a quarterly payment that is made before this 40 quarterly payments. So it will leave us to 41 payments. James is said to make 41 payments. The interest rate, it is 0.12. It is 12%, but remember you divide that by 100. So we have 62,500 is equals to x into what now? Into 1 minus 1 plus 0.12 divided by 4, because it is compounded quarterly, raised to exponent of minus 40 all over 0.12 all over 4. This is for 40 quarterly payments, but James is said to make a start to quarterly pay starting immediately. So we're going to have 62,500 minus that quarterly payment that James started paying immediately, which is equals to x into what? Into 1 minus 1 plus 0.12 over 4 raised to exponent of minus 40 all over 0.12 all over 4. So this is the amount that he started paying immediately. So it's going to be that 40 quarterly payment plus this payment, which will amount to 41 payments. We are going to transpose this one to the right hand side. So we are going to have 62,500 is equals to x x into 1 minus 1 plus 0.12 divided by 4 raised to minus 40 close bracket all over how much? All over 0.12 all over 4. As you transpose this one to the right hand side, it is negative, therefore it will become positive on that side. We have 62,500 on the side. We have a common factor of x on both terms here. We have two terms on the side, which is this term. It's a term as a whole. It's a term on its own. So we have x as a common factor. We take out x as a common factor. Let us look at what will be left here. We are going to have 1 minus 1 plus 0.12 all over 4 close bracket raised to an exponent of minus 40. This is all over how much? 0.12 over 4 plus what? Now when you take out x as a common factor here, we are left with 1. So remember, we are calculating the value of x here, which is your quarterly monthly payment. So we have x is equals to, we are going to divide this whole thing by that. So it is going to be 62,500 all over how much? All over 1 minus 1 plus 0.12 over 4 raised to exponent of minus 40. This is all over how much? 0.12 over 4 plus what? Plus 1. So in other words, we are going to have, let us check what will be our value of x here, which is the quarterly monthly payment. We have 62,500 divided by what now? Divided by 1 minus into 1 plus 0.12 over 4, close bracket, raised to exponent of minus 40, all over 0.12 over 4, and then we have plus 1 there. So James's quarterly monthly payment will be 2,591.77. That will be James's quarterly monthly payment.